a signal that should not exist. It arrived without warning, hidden inside ordinary noise, and for a brief moment it rewrote everything we thought we knew. No explosion announced it. No alarm sounded. Just a pattern that should never have been there. To understand why this signal still unsettles scientists today, we need to return to a time when humanity believed it had finally learned how to listen to the universe properly. Radio telescopes stretched across deserts and mountains, scanning the sky with mathematical precision, filtering out interference, cataloging stars, and translating cosmic static into predictable data. The modern world depends on this quiet confidence, trusting that every signal can be traced, explained, and filed away. That belief matters now more than ever, because our civilization is built on invisible waves. Communication, navigation, defense, and discovery all rely on the assumption that signals follow rules, originate from known sources, and behave consistently across time. We assume the universe is noisy but never deceptive. Then one signal refused to follow those rules. At first, it appeared as a minor irregularity, a brief spike buried inside hours of routine observation. The kind of anomaly software usually discards without human review. But something about it felt different. It was sharp, structured, and precise, in a way random noise never is, repeating just enough to suggest intention, but not enough to reveal meaning. As analysts replayed the data, unease replaced curiosity. The signal did not match any known satellite, aircraft, or terrestrial source. It did not behave like a pulsar, a quasar, or any documented cosmic event. It was too clean to be natural, yet too brief to study properly, vanishing almost as soon as it was noticed. What made the moment truly unsettling was not what the signal said, but what it implied. For a fraction of a second, the universe had spoken in a voice that did not fit any language humanity recognized, leaving behind a single, disturbing question that still lingers today. If this signal should not exist, then what else have we already missed? Once the anomaly was isolated, the search for an explanation intensified, because every signal ever recorded had eventually surrendered its origin, even if that process took years. Teams reprocessed the data repeatedly, stripping away background noise, recalibrating instruments, and comparing timestamps with global databases that tracked everything transmitting from Earth into space. Nothing matched. The signal did not arrive alone, but it did not repeat in any predictable cycle either, which made it impossible to classify using conventional models. Natural cosmic sources tend to announce themselves through rhythm or decay, following physical laws that reveal their nature over time. This signal behaved differently, appearing complete, intentional, and then gone, as if it had no interest in being understood. Attention quickly turned inward. Could it have been a glitch, a software artifact, or an unnoticed error buried deep within the system? Engineers audited the entire signal chain, from the antenna surface to the final data archive, searching for corruption or misalignment. Every component checked out. The equipment had done exactly what it was designed to do. That conclusion raised the stakes. Independent observatories were contacted, and archival data was reopened, stretching back months and even years. Researchers wondered whether similar signals had been dismissed before, quietly filtered out as statistical noise. In the margins of older data sets, faint echoes began to emerge, not identical, but uncomfortably similar, suggesting this event might not have been unique. As confidence in a mundane explanation faded, speculation crept in from the edges of science. Rare astrophysical events, unknown energy processes, exotic objects moving through space too briefly to observe twice. Each idea fit some aspects of the signal, but none explained its structure completely. What made the situation more troubling was the realization that humanity's listening tools were optimized for expectation. Telescopes were designed to find what theory predicted, not what lay outside it. If the universe chose to whisper in unfamiliar ways, it could easily go unheard. The signal had not delivered answers, but it had exposed a vulnerability far more profound than interference. It revealed how much of the cosmos we only understand because it behaves the way we expect, and how quickly that understanding collapses when it does not. As debate intensified, the signal became less about its origin and more about what it represented, because it challenged the quiet agreement between observation and explanation that modern science depends on. For generations, astronomers trusted that with enough data, patience, and computation, the universe would eventually reveal its mechanisms. Yet this brief transmission refused to cooperate with that expectation, remaining stubbornly incomplete and frustratingly precise. Some researchers argued the signal was a statistical outlier, a rare coincidence amplified by human pattern recognition, while others countered that its structure crossed a threshold randomness could not easily explain. That tension split the community, turning the signal into a mirror reflecting deeper disagreements about how discovery actually happens. Is meaning found in numbers alone, or in the questions those numbers provoke? As the months passed without a repeat, the signal began to fade from public attention, but it never truly disappeared. It lingered in conference discussions, late-night simulations, and unpublished papers filled with cautious language and unresolved equations. The absence of follow-up data became its own form of evidence, suggesting the universe had offered a glimpse and then withdrawn it. The implications were unsettling. If the signal originated from a rare cosmic process, it implied entire categories of phenomena still missing from our models. If it came from an artificial source, the silence that followed raised even more troubling questions about intention, distance, and awareness. Neither possibility was comfortable, and neither could be proven. What troubled scientists most was how easily the moment could have passed unnoticed. A slight change in filtering thresholds, a routine software update, or a human decision to ignore an anomaly would have erased the signal entirely. The universe might have spoken, and humanity almost failed to listen. In that realization lay the true conflict. Exploration is not limited by how far we can see, but by what we are willing to recognize as meaningful. And somewhere beyond Earth, whatever produced that signal remains unexplained, waiting silently in the vastness, while humanity debates whether it was ever ready to hear it at all. The moment never received a definitive explanation, but it quietly reshaped how scientists think about listening to the universe, because uncertainty itself became the lesson. The signal was archived, labeled, and cited with careful language, not as proof of anything extraordinary, but as a reminder that the cosmos does not owe humanity clarity or repetition. In the years that followed, search strategies evolved. Instruments were redesigned to preserve anomalies instead of discarding them, and algorithms were adjusted to flag the unexpected rather than suppress it. The signal, brief as it was, forced a shift in mindset, turning attention toward the edges of data where discovery often hides. What lingered most was not fear, but humility. For all our technology, humanity remains a newcomer, listening through a narrow window into an immense and ancient universe. We interpret what we hear through assumptions shaped by our own limitations, and when something falls outside that framework, it can feel unsettling rather than enlightening. Today, the signal still exists as a question more than an answer, embedded in databases and memories as a reminder of how fragile certainty can be. It did not announce a revelation, but it cracked open a door, suggesting there are forms of order, communication, and structure that do not align with our expectations. Sometimes the most important moments in exploration are not the discoveries that explain everything, but the anomalies that refuse to fit. They force us to listen more carefully, to design better questions, and to accept that the universe may be far stranger than we are prepared to understand. Sometimes the smallest shift in perspective becomes the beginning of a new future. A